All right, so just like before, the only things you need to write down and know for each planet are the number of moons, okay, the composition of the planet itself, and the atmosphere. Okay, so composition and temperature, I should say. All right, so Jupiter has 79 moons. The distance from the sun, the period of rotation, and period of revolution are all on your reference table. So you do not need to write them down unless you really want to, but we're going to move pretty quick through this because I want to get through all of the Jovian planets today so that we can move on tomorrow. All right, so the number of moons that Jupiter has is 79, which means that as it was being formed, there was a bunch of dust and other material around it that got pulled into its rotation, to its revolution by its gravity, and they started to coalesce and they formed a moon. Okay. Also, when we say moons, remember, it just means that it's something that is revolving around a planet. So when we were talking before, sometimes it could be an asteroid. It could be a piece of space rock as well. All right.
Can you go back?
You needed to know that Jupiter has 79 moons.
All right, thank you.
Okay, so Jupiter is a gas giant. What does it mean? It means that it is made up of gases, specifically hydrogen and helium. Hydrogen and helium at standard temperature and pressure are gases. So on our planet, they will be gases unless you force them to be something else. Okay. Now, it says the remaining 1% are trace elements. So there's only 1% total of iron or sulfur or carbon or any other gases that you can think of. Right? There is not one solid surface on Jupiter. So we could not go there and land there and patrol around, basically. That's basically what it says. Okay. Now, as you go closer to the planet itself, it's covered in clouds, these basically these gas clouds, and they become denser and denser and denser until you do hit this liquid metallic hydrogen ocean that's closer, that is on the surface. Okay, so again, we still cannot land there. We cannot go there or send a rover there for that reason, because there's nothing to land on. Okay, right? So it does have a very small, solid iron core. Okay, so all this stuff you need to know. Okay, so here, if you're looking at it, right, in the core, it's very small. It's made of rocks and metals and hydrogen, different type of hydrogen compounds, right? And then there's a bigger layer of that metallic hydrogen, and then after that, it's that liquid hydrogen, and then there's a gas hydrogen, right? And then there's the clouds. So the difference between Jupiter and Earth, if you look down at the bottom here, right, we have a core, a mantle, a crust, and then the atmosphere. Whereas they have a core and then it just never hardens. Yes, some of our mantle is liquid, but it's not the same because we don't have that. We have that crust in between that is solid. Okay, so here's just a picture of it. Kind of cool. You can see the liquid metal. Here's just another picture. And then it has that giant red spot. Fun times. Okay. There are the Galilean moons. All you need to know about them is there are 4. We're going to skip over them because I really don't have time to do all that. Okay. Let's see if this video will work. So this is a comet impact on, I think it's on Jupiter, if it works.
Before Newsnight, more of the unfolding story behind the week's dramatic events on Jupiter. Tonight, how the comet Shoemaker-Levy was turned into a train of fragments thousands of miles long.
Okay.
Hi.
before things turned nasty. 2 years ago, the comet passed within a few thousand kilometers of the planet's surface, a hair's breadth in astronomical terms. The tension between falling down to the planet and continuing to orbit was too much. Cracks and fissures opened, vast quantities of dust broke off. As the comet wrenched itself clear, it was torn to pieces.
Okay, your timer alarm's on.
The ruptured rock retreated out to space in a train of rubble 10,000 kilometers long, with a string of mountainous fragments in Saturn. But its fate was sealed. Jupiter not only had torn it apart, but fatally changed its orbit. So when it came back, there would be no near moon.
So, eventually when it comes back, it will hit.
The comet's large core fragments started to slam into the atmosphere, mountains of rock vaporizing in seconds. Tonight, the largest rock struck. A fireball rose hundreds of kilometers above the surface, creating a hole in the atmosphere larger than Earth. Shock waves will ripple round the planet for days, and its surface may be changed for weeks. In the end, Jupiter's stormy red atmosphere will close over the scars left by Ganymede. But there are always more rocks out there, and other planets, where such huge impacts would not be so easily.
Right, that's after the last of this week's Jupiter Animations, which looks at the lessons that Earth can learn from this momentous collision.
So basically, guys, a comet came close to Jupiter, then it actually ended up hitting it, and it changes the surface. It's kind of like when we had the other planet knock into us, and it changed how our surface is, and now we're livable on Earth, whereas before we were not. Okay, so here's a picture of Saturn. We are moving on, right? So its period of rotation, so it takes 10.7 hours for it to rotate around itself. That's not a lot of time, right? Its period of revolution is 29.4 Earth years. Okay, its distance from the sun is 9.2 astronomical units, but the number of moons is 62. It has 62 moons, so it's a lot more than we have, which should make sense because it's a bigger planet than we are. Okay, it has the second fastest winds in the solar system at 1,800 kilometers per hour. Okay,
Can you go,
what?
can you go back?
You need 62 moons. That's all you had to write down. Everything else is on the reference table. Okay? This is what you need to write down. So the smooth appearance makes it seem like it's all calm and everything, but it's not. It has the second fastest winds in the solar system, like I said, at 1,800 kilometers per hour. That's crazy. So that's going to create cyclones on Saturn. And I'm going to see if this video works, because again, remember, YouTube was down all day so far, since like 6:30 this morning.
We've always thought of Saturn being this serene body that looks like a pearl in the sky. Confused to it as clouds. What we're seeing is that as you go through those hazes, you get down to the depths of Saturn, you find a roiling atmosphere. And the cyclone is probably one manifestation of this dramatic dynamics. We didn't realize that there was a cyclone in the South Pole a year ago. What was the surprise was we see essentially the same type of a feature in the North Pole. The North Pole has a hexagon around it. Now, these cyclones on Saturn are huge. You can fit at least one Earth in one case and two Earths in another case inside these things. And they have powerful winds near the center, about 300 miles an hour. So in a lot of ways, these are the most powerful cyclones ever seen. Both Earth and Saturn work on the same laws of physics, but the Earth has this vast reservoir called an ocean, which can pick up heat and absorb it from the sun, and then release it under the right conditions to create a hurricane. On Saturn, we have internal heat deep down, being powered by processes that are happening deep in the atmosphere of Saturn. What it shows us is there's some bizarre physics going on Saturn. That is, it's drawing large amounts of energy from the inside of Saturn to power these storms. We're talking again about a storm system that's about 20,000 kilometers across, or even larger. That's a gigantic storm system. So it's the largest storm system of this type we've seen anywhere in the solar system. And now we've seen two of them on both poles. It shows us that Saturn is special, and we should keep studying it.
All right, so it does have the same interior as Jupiter, but instead of having a small core, it has a bigger core, but a smaller liquid metallic hydrogen layer. Okay, if you look, they are still made up of the same material. Okay, but they're just the size differences of it in comparison. Okay, so Saturn does have visible rings. Even though all the Jovian planets have rings, Saturn's are much more visible. And unfortunately, I can't find the story, but on Friday, there was a newscopter that was able to actually capture pictures of Saturn from Earth. Okay?
From a distance, Saturn's rings look like a single flat disk. However, they're actually thousands of separate rings, each only a few miles wide. When the Cassini probe flew past, it detected billions of pieces of ice and mesh apart. But they never form into larger moons because Saturn's immense gravity tears them apart. Scientists are only just beginning to figure out how the rings formed in the first place. There are many ways to make rings. When Cassini analyzed Saturn's outermost E-ring, it detected ice grains with a particular chemical signature that aren't found in any of the planet's other rings. Scientists wondered where this ice came from. Then, in 2005, they got lucky. Cassini witnessed geysers on Saturn's moon Enceladus, blasting out giant plumes of ice crystals into space. When it analyzed the plumes of ice, it found it had the same signature as the ice of the E-ring. Saturn's gravity was capturing the ice crystals ejected from Enceladus and pulling them into the planet's outer rings. But the real mysteries of the gas giants lie deep inside them, tens of thousands of miles beneath the clouds. This is where the real action is. It's a place so extreme, it challenges the laws of nature.
Okay, so I think that's so cool, and I actually was able to find for you guys the story. I just posted it for you of how a newscopter was able to see Saturn. If you look at it, it looks pretty cool. It looks a little grainy, but if you think about it, when you're taking pictures from here, you know, it's gonna be a little bit grainy, okay, because you're taking pictures of something that's really far away. If I can show you really quickly, let's see. I literally just posted it. So let's see. Thought you guys would find this pretty cool.
Weather's been improving all day, and I hear we're going to do some stargazing or planet gazing tonight with rings.
Yeah, I mean, it worked so well last night, guys. I mean, we showed this shot before. They want to get this shot better. I mean, is that not even better than last night? I mean, that is Saturn from Chopper 4. You can see the planet Saturn. Wow. You can see the rings of Saturn as well. That is just absolutely amazing. When we showed this yesterday, we had such a huge response. We did put it on our website, NBCWashington.com, so you can take a look at it a little bit better. And if you've got a telescope, binoculars, anything, that's what it looks like out there right now. I mean, it is absolutely spectacular across our area. The weather, by the way, in Saturn, not so good. Plenty of clouds. It's a very gassy planet. So, yeah, not the best day to get outdoors.
Right? Pretty cool to see that you can actually see that from Earth, to be honest. Right? So, all right, we're going to move on to Uranus, if it lets me. Okay, so Uranus, right? We have a period of rotation of 17.2 hours. Its revolution is 83 Earth years. So if you're on Uranus and you're there for 1 year, everybody else aged by 83 years on Earth. Okay? The distance from the sun is 19.2 astronomical units. Here's what you need to know because it's not on the reference table, right? The number of moons is 27. Okay? The other thing you need to know, right? The tilt of the axis. We know that our tilt of the axis is how much?
Is it 23.5?
Right, 23.5 degrees is for us, right? So we're like a little bit, not a big deal, right? Uranus is 99 degrees. So instead of being where we're here, Uranus is like this, basically. Okay, it's almost completely on its side. It's a little bit more than just be rotating on its side. That's important because Uranus is different than, it doesn't follow the same pattern when it comes to the tilt as pretty much every other planet in our solar system. So that's something you need to know. Okay.
Why is it on its side?
It's just the way that when it was formed and also the magnetic field that is created, pretty much. Okay, so it's 99 degrees. Uranus will be the coldest planet. You would expect it to be Neptune because that's after Uranus, but Uranus is actually the coldest planet in our solar system. Okay, it does have rings, like I said before. The Jovian planets do have rings. Okay, but Uranus's rings are made up of rock and ice. Okay. And that's how they know that it's one of the colder systems. And I'm going to show you a picture in a second that actually shows you the rings from a telescope. Or I should say from a satellite. Okay, so here, these are the rings. Now, they're not as defined as Saturn's, but these lines here are the rings that you can see from a satellite that was sent towards them. Okay, it's still rings, but those rings are made up of chalk and ice. All right, those 27 moons are, or all of the moons, right, are named after Shakespearean characters. All right, those are the natural satellites. So you have Puck, Miranda, Titania, Umbriel, and Oberon. Right, those are just some common names of the satellites. Okay, then you have Ariel, right, is another one. Okay, they're Shakespearean characters, and if you don't know who they are yet, you will at least know Puck and Miranda over the next couple years in your English classes. Okay, remember, if it's on here, you definitely need to know it. Right, so you need to know that the 27 moons are, or the 27 of the moons are named after Shakespearean characters. Okay, these are the most popular ones, or the ones that that NASA is actually following and keeping an eye on. Okay, this is what they look like. They're all different shapes, or all different sizes, I should say. Right? Kind of fun. Let's see. A lot of videos in today's lesson, which is good. Right, so here's just Uranus. You could see its size in comparison to Earth is much, much, much larger. Right? Just got to fast forward a little bit. Okay, so its color, everyone thinks that its color is just because it's cold. It's not just because it's cold. It also has to do with wavelengths, the way that light is absorbed and reflected from the sun, and depending on what's in the atmosphere. The other day at my house, let me see if I can pull up this picture really quick for you guys. This was the sunset. You guys see that? See how it has like pinks and oranges and yellows, right? The sunset that had happened is the way that the colors are is basically the light refracting and reflecting and being absorbed through the atmosphere around us. Actually, believe it or not, the pretty colors mostly come from pollution, okay, and how it reflects off of that, and that's how you get those really pretty sunsets, okay? So it's the same reason why Uranus is blue. Okay, so Neptune is also a blue planet. Okay, it's the last recognized planet in our solar system because we no longer recognize Pluto as a full planet. Okay, it has 13 moons. All right, so when we're looking at this, its period of rotation is very small. It's only 16.1 Earth hours. All right, that means 60 times 16.1, right? 60 minutes. Its period of revolution is 163 Earth years. And again, you would assume that the period of revolution is much larger on Neptune, because if it's the last recognized planet, it has to cover more distance, okay, to get around one time on the sun, versus Mercury, which is super close. And all those pictures that I showed you where Mercury was really close and it's going, and Neptune was like very slow in its orbit. The number of moons that we have are 13. Okay, that's important. Again, there's no rhyme or reason to how many moons each planet has. We have 1. Some other ones have 0, right? Then we had 27 for Uranus, 13 for Neptune, 60-something for Saturn and Jupiter, you know, so there's no pattern. So don't try to find one. There's no pattern on the number of moons. Okay, so let's talk about Neptune's atmosphere. Okay, this has the fastest winds in the solar system. Right, they're moving at 2,400 kilometers per hour. The fastest winds in our solar system. Okay, what I was just saying, it all has to do with the color, has to do from our perspective of how the wavelengths of light are being absorbed or released, or reflected, I should say. My shirt right now is the color blue, but my blue to you might be slightly off. Okay, it's how you are, excuse me, how you are perceiving it, and your eye can perceive it differently. Okay, what this tells me is that because my shirt is blue, that the one wavelength of light or color is reflecting back is the blue part of the spectrum. Okay, you guys all know about Roy G. Biv, right? So B for blue. All right, so anytime you see a color, it's because that's the color that's being reflected. Okay? You guys okay with that?
Yes.
Okay, good, you're still there. Fantastic. Can I move on? Or should I?
Yeah.
Okay. So, let's talk about its interior now. It has a core. Every single planet has a core, which is good. but its core is made up of rock and ice. Okay, in this case, Neptune has a mantle, and it's made out of that water, ammonia, and methane. Okay, but they're all ices because it's so cold. All right, remember, water is H2O, ammonia is NH3, and methane is CH4. Right? Remember, I told you you need to know what those chemical compositions look like. All right, its atmosphere is hydrogen, helium, and methane gas. Again, it's gases, and then its upper atmosphere has some clouds to it. Okay. So Neptune's moons are named after sea gods and goddesses. So like Triton and any of those fun things. And they actually named the largest moon Triton. Okay. And it's going to orbit in retrograde. What is retrograde, guys? Do you remember what retrograde is?
We were talking about that for the moon, but I don't remember the exact definition.
Okay, so retrograde just means backwards. That's all it means. So it looks like it moves backwards. Okay, so it's going to move in the opposite manner than all of the other Neptunian moons. Right? When we say Mars is in retrograde, from our perspective, it looks like it's moving backwards, but it's really not. It's just because of our perspective, it looks like it's moving backwards. All right, let's see. All right, so quiet. Okay, so we have the mantle, so on and so forth, the innards. All right, let's see, is there anything? Okay, so something that I do want to point out, okay, as years go on, right, they're starting to find that the cloud cover is increasing on Neptune. Now that's important because that's telling us that something is going on Neptune that is creating a change in the atmosphere or in that cloud cover. The more cloud cover you have, remember that the sun's rays can stay in, and the more of a greenhouse effect you can have. So we don't know yet, but it could be that it is actually increasing in temperature on the surface. Okay? I am running out of time real quick, and I want to cover Pluto. All right, so this is Pluto. This is the first shot we've had of Pluto till now. Okay, so some fun facts about Pluto. Now, this stuff is not on your reference table, so you need to take a picture of this slide. Okay, so the period of rotation is 153.3 hours, okay, which is a lot. The period of revolution is 248 Earth years, which makes sense because it should be it's the furthest dwarf planet that we have from the sun. The distance from the sun is 39.5 astronomical units, and the number of moons is 5. So Pluto does have natural satellites. That's interesting. Okay, you guys all took a picture? Good. So now,
how many moons?
5.
Okay.
Okay. So it was discovered in the early 20th century, and it was originally classified as the 9th planet. I do not know if I can show you guys this because it's like 2 minutes left of class. It's not working. Okay, so, lovely. I love when things work for you, right? Okay, we are here. Okay, so we know that it is extremely off of the x-axis when it comes to its orbit, right? Here's Pluto's surface. Looks interesting, right? It's got some peaks, it's got some valleys, it's got some plains, as you can see here, the smooth spots, right? It's got some craters, some pictures. Okay, so Pluto's atmosphere. Look at the difference between the size of Pluto's atmosphere and the size of our atmosphere. It has a very, very, very large atmosphere. Okay? That atmosphere, and then I'll be done in 1 second, guys. is made up of 97% oxygen, approximately 2.5% methane, and 0.5% carbon monoxide. Okay. So here's just its Pluto and its satellites. These are some of the important satellites that you should know. So Styx and Charon and Kerberos and Hydra and Nix. Okay, and on that note, that's where I'm going to end for today. All right, you guys have a good one.
Bye.
If you have any other questions, I have extra help today at 5.
Have a good day.